low enough that others are not listening, hearing it? Yes, it's a a hydrocarbon that has carbon-carbon triple bonds. Okay. How many of these three bonds are sigma bonds and how many of these three bonds are pi bonds? Anybody?
There's one sigma and two
Two
pi.
pi's. What's the hybridization state of the carbons that are triple bonded to each other?
SP.
So what should be the shape at those carbons?
Linear.
Exactly, with a bond angle of 180 degrees. That's why, is this okay for me to draw? If I drew something like, for example, is that an accurate drawing of an alkyne? Can an alkene be angular? Can an alkene be angular?
Yep.
Absolutely, because that's trigonal planar. It's triangular. It's angular with bond angles of 120 or so. But can a triple bond be angular? No. So when you're drawing it, please think about it. That yep, that's supposed to be a triple bond, so it has to be linear. We need to draw it accordingly. Sounds okay, everybody? Okay, let's talk about naming alkynes, IUPAC naming of alkynes. So just like all other cases as we've talked about IUPAC system, the word alkyne is actually a combination of three parts. Alk, ine, and E at the end. What does alk tell us, anyone?
The number of carbons.
In what?
The number of carbons in the molecule.
No.
The parent chain.
In the parent chain, okay.
And what is the parent going to be for an alkyne? The parent is going to be the longest chain with, exactly, included in it. Even if that means that you end up choosing shorter of the different options, but the triple bond should be part of the parent. You good, everybody? What does the ine tell us?
Triple bond.
Exactly, the parent has a triple bond, has a carbon-carbon triple bond. And what does the E tell us?
Hydrocarbon.
The molecule is a hydrocarbon. There are no heteroatoms, no oxygens, no nitrogens, no. It's a hydrocarbon. Now, when it comes to naming the carbons in the parent chain, when you're naming the carbons in the parent, not naming, did I just say naming? I did. Numbering. When you're numbering the carbons in the parent chain, the carbon-carbon triple bond should get the smallest possible position number. And if there were more than one triple bonds in the parent position, so the combination has to be the smallest. Everybody okay? Yes? So let's try out a few. Could you pass, please? No, Anna. Oh, please take pass. Okay. First page.
Can you pass these?
Let's start learning how to name. So you guys seen that? Did everybody get a copy?
One more.
Okay, here you go. There you go.
One more.
There you go. Did you guys get one? No, Annika, you didn't? There should be some over there. Okay, did everybody get a copy? Okay, let's start with the first one. So, first job is to choose a parent. What would the parent be? I'm sorry? 6 carbons?
Yep.
What you're saying?
1, 2,
Okay.
3, 4,
So,
5, 6.
Good. And then numbering of the parent. Should we go right to left, left to right, or in this case,
It doesn't matter.
Because
It doesn't
it's very
matter.
symmetrical, right? So 1, 2, 3, 4, 5, 6.
Yep.
Okay, let's start naming it. So first comes groups. What are the groups?
Methyl.
2,5-dimethyl.
And then comes the parent. So parent is hex, right?
Mm-hmm.
Where is the triple bond? So dash 3, fine. Everybody okay?
Mm-hmm.
Okay. Let's see if we can draw out the second one. I hope my name is correct. 4,4-dimethyl pent 2-ine. So what's the parent?
Pentine.
Pent 2-ine, right?
Yep, pent.
So the ine is on the 2 carbon.
Mm-hmm.
So if that's
One,
mine
three,
2,
4,
3,
1,
4,
2, 3.
5. Agreed? Is that pent
3,
2-ine?
4, 5.
And then we have 4,4-dimethyl. 1, 2, 3. Good? By the way, can there be E or Z, cis and trans with a triple bond? Louder? Well, that's my question. Is it possible? If you have an alkyne, is it possible to have cis or trans? If it's linear, it's in one line, everything is 100, the bond angles are 180 degrees. Is it possible to have R's on the same side or different sides?
No.
No. There is no cis and trans E or Z with respect to alkynes, not possible. Exactly. Okay, next one. Please go ahead, tell me what will be the parent. Did you say decyne?
Yeah. Deck 3
Okay, so are you saying 1, 2, 3, 4,
Yep.
6, 7, 8, 9, 10? Everybody agrees?
Mm-hmm.
Okay, let's name this. So, groups. Go ahead, what would you call this? 7,7-dimethyl, okay. What about this guy?
That's a benzyl.
That's a benzyl. So who comes first, dimethyl or benzyl?
Benzyl.
Okay, so 5-benzyl, right? Agreed?
Mm-hmm.
7,7-dimethyl what?
Decphreine.
Dec 3. Everybody agrees? Okay, next one. Please go ahead. Take a look at the next one.
10.
10, is it again? Dec 10?
I think so.
I don't know.
Free.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, you're right. It is. Ah. Okay. Is it 10? Is everybody
Yep.
agreeing with that?
Well,
What's the parent? Is it 10 carbons? But that's a carbon right there, part of the parent.
Yeah.
Agreed? Okay, so which side should I start naming, numbering the parent
I think from that side.
From this side or this side?
That side.
This side, why?
Because it's the methyls would be lower.
And also the chlorines.
Oh,
There are 3 chlorines on this,
Oh,
which will be
good.
1, 1, 1 and
Yeah.
not 10, 10, 10.
right. Mhm.
Right?
Yep.
Exactly. 3, 4, 5, 6, 7, 8, 9, 10. Exactly. So we should start from here because you have 3 chlorines also here. Remember that if the alkyne has the same numbering from either end, then the groups should get the lowest combination. But first alkyne, first priority is alkyne, the triple bond. Okay, let's start with the groups then. Who comes first?
4.
So what should I write?
1, 1, 1
Trichloro, okay.
7-ethyl.
7-ethyl, then comes
4.
4,4-dimethyl
4,4-dimethyl.
and Dec dash
Good. Dec
2,8,
2,
8,
and
and then dash what?
di.
Diine.
Ion.
Because
Dine.
the di is with the ine. Now, do you guys remember when we learned how to name alkenes last week? What do we do if there were more than one alkene in the parent?
We add an A. So it would be deca, not dec.
Same thing here.
Oh.
So deca, 2,8 diene, because there are two ions, diene. Everybody okay? Make sense, everyone? Please go ahead. Please, can you guys do the remaining two? Draw the structure and name the compound. Please go ahead.
Mhm.
6, 7.
Think I got it. Oh, the next one.
Okay, just a couple more examples of on the. By the way, what are the answers to those? So, 4-ethyl, 3,4-dimethyl, hepta 1,5-diene. So hepta 1,5-diene. 1, 2, 3, 4, 5, 6. Oh, 5, 6. Okay, sorry. 1, 2, 3, 4, 5, 6, 7. So that's my parent. Am I right?
Yeah.
And then 4-ethyl, 1, 2, 3, 4-ethyl, 3, 4-dimethyl. Is that correct?
Mm-hmm.
And what's the name for the last one?
2-chloro, 6-cyclopentyl, 7,7-dimethyl, oct-4-ine.
Perfect, but can we slow down? Can we try again? 2-chloro, what's next?
6-cyclopentyl.
Chloro, 1, 2, 3, 5. Yeah, it's 5.
Oh, 5.
Cyclopentyl. Then 6,6-dimethyl hept 3-ine. Is that correct? Is that what you got too as well, Carter? Except for that 6 versus 5. Cool. What about if you had ene and ine together? We had double bonds and triple bond in the same molecule. Those are called enines. You have alkanes, alkenes, alkynes, alkenines, because you have both ene and ine. So, what's the parent? The parent is going to be the one that has both in it, as if possible. And I think I've drawn all structures where that is the case. Both triple and double bonds are part of that parent in this case. Numbering to get the smallest combination for both ene and yne if possible. Again, it's all about if possible. So that's why I started numbering from that end, because then that's closer to the end as opposed to starting from here. We all agree?
Mm-hmm.
Okay, groups. Who comes first? Bromo or T-butyl?
Bromo.
Okay, so 1 bromo, 3 tert-butyl, right?
Mm-hmm.
And now the parent. Oh, sorry. Parent. So parent is what? Hex. It's an ene-yne.
Mm-hmm.
So what comes first?
Ene.
So what position is the ene on?
1.
Then comes the yne. What position is the yne on?
4.
Exactly. So basically, that's why IUPAC is such a versatile way of naming organic compounds, because you can take this big thing and break it up into parts and just add wherever things need to be added. So it's 1 ene, 4 yne. Yes?
Do you only add the A if there's multiple of one?
Yes.
Okay.
That's why I have those, right. If you had multiples of either, then the A comes in. Exactly. So let's try this one. What's the parent? Would you agree? 1, 2, 3, 4, 5, 6, 7, 8. Do you agree with my numbering?
Yes.
Once again, the goal is to give the ene and ynes the smallest combination first. Groups. So we have 3, 6 dimethyl. Any other groups? No. Now the parent. 8. What is 8? Oct. But notice how there are 2 enes. Octa. Exactly. And then first the ene. What positions are the enes on?
4, 7.
4, 6.
4, 6.
4, 6. Di-ene. Agreed? And that's not di-ene. That's
Dine.
dine.
Somebody thank you.
I know. Di-ene. And now the yne. The E at the end only comes once. That's the one E at the end telling us this is a hydrocarbon. But does that sound okay, everybody?
Mm-hmm.
Can you please give that one a try? Tell me what would be the name for the third structure here? Yes? What happened?
1 iron. Wait.
It's on, the triple bond is on one carbon.
Oh, yeah. Okay. Never mind.
No, you're good.
Yeah.
The alkyne is on carbon.
And 4, 6 is.
The ene.
Oh,
Exactly.
Yeah.
The dots, that's the
I wasn't
ene.
noticing the 2 bones. I thought it were
Fine.
3. I was like, what? Got it.
Okay, could you please try this last one? Tell me what you get as the name. You have it, Dash? Anybody else has it?
I have 9 fluoro hex 18.
So. Hex what? Hex? Are you sure?
Oh, sorry.
It's way more than 6.
Deck 18.
Deck 18. Is that what you said?
Yes.
Okay. And then? But there are 3 of those.
Oh, okay, so it would be deck better, yeah.
3 of those.
I was thinking because there was only 1 of the in
If you have more than one of either,
either.
the
Okay.
A will go in.
Okay.
And then?
1, 3, 6,
1, 3, 6, what? No.
Try.
Triene.
I'm trying.
I'm trying.
Make sense, everybody?
Uh-huh.
So
Oh.
if there is more than one of either the double or the triple bond, then you got to use that A. But if there's only one of each, then you don't need it. But the ene comes first. It's an ene. Ene comes first then. Ein is the parent. By the way, what if oh shoot. Oh, we missed. Sorry, hold on. Can we come back here, please?
Yes.
Aren't we missing stereochemistry?
Oh, yeah, we are.
If there's an E, you should think about E
E
or
and
Z.
Z.
Please go ahead and add those for all three of
Easy.
them.
Oh, good point. Well, that would be
2, 1.
central. I don't know.
1, 2, 2, 1. That would be E. And it's at 1.
Okay, so what is this you said, Carter?
1 E.
This is E. I don't have to say one just because there's only one.
Okay.
If it was
E.
more than one, then of course we have to give the number. But do you all agree that that double bond is E?
Yeah.
Okay, good. How about this one? 4Z and 6Z. Are you sure?
6E.
6 is E. This is priority 2, priority 1, right? And that's priority 2, priority 1. So 2s are on opposite sides, 1 are on opposite sides. So that is 6E. Do you all agree? Everybody? The triple bond does not have stereochemistry, but the double bond does. How about this one? This is Z, definitely. Everybody okay? Please, yeah, don't forget, if the stereochem should be shown, you have to include that. So what about this kind of thing? I mean, what's the parent and how do we number the parent? Should I number the parent starting from the alkyne side or should I number the parent starting from the alkene side? Who takes priority for the numbering?
Okay.
The alkyne.
What's the parent? What gets priority is whoever is on the end. Who's on the end? That should get the smaller number if there were a choice. If there were, whether you go this way or the other way and the numbers are the same, then the alkyne gets priority over the alkene. On the other hand, if our first goal is to find the smallest combination first. If the combination is going to be the same, then you choose alkyne over the alkene. Does that make sense, everybody?
Yep.
So the correct numbering will not be the blue one, it will be the orange one, 4, 5, 6, 7, 8, 9. So let's name this. Start with stereochem. So first thing is stereochem, then groups, then the parent. Is there stereochem to be shown here?
Yes.
What is it?
6.
6Z.
It's Z. Okay. You can say 6Z, it's just that the 6 is redundant because there's only one place where the stereochem can be given, so the 6 is not necessary. Okay, groups.
1 chloro or 8 chloro.
8 chloro,
7 ethyl.
7 ethyl,
No.
Oh, yeah, see.
non. There's only one of each, so we don't need an A. Oh, careful, it's not 8. Start at the smallest. It's always the smallest number, right? 6 ene and
Freeine.
For the Z, don't we say 6?
again, since there's only one stereochemistry, this is not necessary.
Oh.
It's not, but if there were more than one, then you have to give.
Oh.
But if there's only one, you don't have to give. Yes, Karen?
So if we were shown a problem where it was just the name and it didn't say 6Z, how would we determine?
Say that one more time.
If we were given just the name of the
Yeah.
compound,
We wouldn't know where to put it?
how would we know where the double bond would be?
It has to give the position.
So,
Are you saying,
so I guess she's showing that,
just a
okay.
second. Are you saying, Carrie, that if the name did not give the position of the double bond, how would you know? Well, you can't.
Exactly.
They have to give.
So you-
Otherwise, the name is incorrect.
So you'd never put that, like say we didn't have the upper part, and you give us that.
Say that again.
Say you don't have this part, you don't see it.
Oh, if you don't
How
have
do
the
we make
structure.
it with this?
Well, so, Carrie, for your question, in
Oh.
the position of